Good day everyone. In the last video, that is integration part 3, you learned 4 new formulae. Integral tan x dx, integral cot x dx, integral secant x dx and integral cosecant x dx. And you learnt a new method, integration by substitution. Using those, let us do few sums now. The first one, I is equal to integral 1 by sin x cos squared x dx. You cannot integrate as it is. Even if you take it to the numerator, you will get cosecant x secant squared x dx and nothing can be done. So here, I am going to write the 1 in the numerator as sin squared x plus cos squared x. The denominator I am writing as it is, okay? So now, the numerator consists of 2 terms and the denominator 1 term. So now, I am going to split it into 2 integrals. The first one will be integral sin squared x by sin x cos squared x dx plus the second integral will be cos squared x by sin x cos squared x dx. Okay? Now, in the first one, 1 sin x you can cut, correct? So, you get sin x by cos squared x. You write sin x by 1 cos x as tan x and 1 by cos x, that is the other part, that will become secant x dx. Okay? Then coming to this one, the cos squared x will get cut. You will get 1 by sin x, which is nothing but integral cosecant x dx. Now you have direct formula for the 2 integrals. So the first one you will get secant x. The second one you can write any one of the 3 formulae, log mod cosecant x minus cot x plus c. Don't forget to add c. Okay. So in this sum, what you have to remember? The 1 in the numerator. If you write it as sin squared x plus cos squared x, that will help you in some sums. So these are all like some concepts which you have to remember. Now let us see a different sum. I is equal to integral tan x tan 2x tan 3x dx. You can see there is a relation between the angles, isn't it? You will get x plus 2x is equal to 3x. So now I am going to write x plus 2x is equal to 3x. Take tan on both sides. What will you get? Tan of x plus 2x, that will be equal to tan 3x. This is like tan of a plus b. You know the formula. Tan a plus tan b by 1 minus tan a tan b. So I am writing tan x plus tan 2x by 1 minus tan x tan 2x, that will be equal to tan 3x. Let us cross multiply this. So I will get tan x plus tan 2x, that will be equal to tan 3x minus tan x tan 2x tan 3x. Okay? That is these 2 terms I am multiplying with the tan 3x. Now, see the sum. You have tan x tan 2x tan 3x. So, you bring that minus to this side. You will get tan x tan 2x tan 3x, that will be equal to, you are already having here tan 3x. Bring these 2 terms here. You will get minus tan x minus tan 2x. So now the product of the 3 terms you are now getting as a difference of 3 terms. So now the I can be written as, instead of this you can write this. So you will get integral tan 3x minus tan x minus tan 2x dx. You know the formula. Integral tan x dx is equal to log mod secant x. So now I can write this as log mod secant 3x whole by 3, because the coefficient of x is 3. For the second term, minus log mod secant x. The third one, log mod secant 2x by 2 plus c. Do you follow? So, in this sum, we used a different concept of writing one as sin squared x plus cos squared x. In the second one, we used that angle, no, x plus 2x, that relation is equal to 3x. We took tan on both sides and the product of three terms, we wrote it as some difference, that format, and then we use the formula. Hope these two sums are clear to you. Okay. See the third sum. Here the I is integral sin x by sin x plus a dx. This sum you can do in two ways. One way is you can substitute that x plus a is equal to t, so that the x will become t minus a, and you can find dx and you can proceed. But I am going to follow another method. Any method can be followed. Okay. So now I am going to write my I is equal to integral. In the numerator, I am going to add and subtract a, because if I add and subtract the same number, it will be the same, right? So I am adding and subtracting a. By the denominator, I write as it is. Okay. Now here I will group these two together, and this term will be like, you can treat it like sin of a minus b. You know the formula. Sin of a minus b is sin a cos b minus cos a sin b. I am going to use it. So I will get sin x plus a cos a. Okay, sin a cos b minus cos x plus a sin a divided by sin of x plus a dx. Okay. Now we can split this into two integrals. In the first part, this sin of x plus a and this sin of x plus a will get cut. Cos a is a constant, so actually I can write it outside the integral. I will be only getting integral dx. Okay. Coming to the second part, there is a minus sign, let us put it. Sin a is a constant, I will write it outside the integral. Cos of x plus a by sin of x plus a is nothing but cot of x plus a dx. Do you follow? Now, this cos a I can write as it is. Here I will get one x, because it is like 1 into dx. So that will be x. Here minus sin a you write as it is. The integration of cot of x plus a will be log mod sin of x plus a. Okay. Then there will be one c. Here don't write cos ax, that is wrong. It is better you write x cos a minus sin a into log mod sin of x plus a plus c. This method I thought will be a bit easier, because you should substitute, then again replace that t. So I am teaching you by this method, but both the methods you can do, you will get the same answer only. Now we are going to see how to integrate integral subtype integral 1 by 1 plus or minus tan x, that is 1 by 1 plus tan x, 1 by 1 minus tan x, 1 by 1 plus cot x, 1 by 1 minus cot x. This is one separate model or type we can call. Now, if I teach you one, you can do the other three yourself, because a similar pattern only you have to follow, right? So now, I will take I is equal to integral 1 by 1 minus tan x dx. I will teach you this. You have to do the other three yourself. Then only it will be clear to you. Now, first the tan x I am going to write as sin x by cos x. Okay. If you have cot x, you write it as cos x by sin x. Then take LCM for the denominator, and automatically this cos x will go up. So I will be getting cos x here, and here I will get cos x minus sin x dx. Okay. So first what did we do? The tan x we wrote it as sin x by cos x. Then We took LCM for the denominator and then that cos x goes to the numerator. Now listen, the next step is, now you multiply the cos x by 2 to compensate, you divide, okay? I will tell you why I do this. So I get now 2 cos x, okay? Now I am going to add and subtract sin x. I am going to add and I am going to subtract sin x. In the next step you will understand why we do these things. Okay. So what have we done here? Into 2 by 2. Then we are adding and subtracting sin x. Here you have cos x. So you are adding and subtracting sin x. If you have sin x, you have to add and subtract cos x. Right. So now, next, half, okay. Now this 2 cos x I will write 1 cos x here and 1 cos x here, right, by cos x minus sin x dx, right. The 2 cos x I am splitting it into cos x, one I am adding with plus sin x and the other one I am adding with minus sin x. Now I am going to split it into 2 integrals. So now that half is common. So let me put a bracket. Integral cos x plus sin x by cos x minus sin x dx. Okay. Plus cos x minus sin x by cos x minus sin x dx. The second, both will get cut. You will straight away get only integral dx. Now, for easier understanding, I am going to represent this as I is equal to half into I1 plus I2. That is, this integral I say I1, this integral I say I2, so that it is easy for us. Okay. So now, I will mark this as my step 1 because I am going to do I1. I am going to integrate that separately. I am going to integrate I2 separately. Then I will add them together. Okay. So now let me write my I1 is equal to integral cos x plus sin x by cos x minus sin x dx. Now you put cos x minus sin x is equal to t, because when I differentiate, for cos x I will get minus sin x, for this I will get minus cos x. So if I take a minus sign out, I will be getting the numerator as the dt part. Okay. So now I am differentiating. So minus sin x minus cos x, that is equal to dt by dx. So I will write this as sin x plus cos x. Sin x plus cos x or cos x plus sin x, both are same. The dx I will bring here, the minus I will take here. Do you follow what I have done? So now sin x plus cos x into dx is equal to minus dt. So now what will happen to I1 now? Minus I will put here. You will get dt by t, which you know it is log mod t plus c1. Why I put c1? Because I have 2 integrals. I will put c1, c2. Then I can merge both. So now this is equal to minus log mod. What is t? T is cos x minus sin x plus c1. So this answer I will keep as 2. Do you follow how I have integrated the I1 part? Okay. Now let us do I2. I2 is nothing. It is just integral dx. So you write x plus c2. You mark it as 3. Actually these markings will help you for organizing your steps clearly. Now you substitute. Okay. Substitute 2 and 3 in 1 because 1 is our final step. So I will get I is equal to half. Then I will put a bracket. I1. What is I1? that is minus log mod cos x minus sin x, right? I won't write that C1, that I will put afterwards. For I2, I get only one x. That is C1, C2, everything I will put one C. So now the answer is half minus log mod cos x minus sin x plus x, then plus C. Do you follow? So this sum is a special type, we can say. So you do the other things, that is integral 1 by 1 plus tan x, integral 1 by 1 plus cot x, integral 1 by 1 minus cot x. If you do that, you will be very clear about these 4 sums. Do you understand it clearly, ma? Shall we go to the next model? Now let us see one new model in which there are 2 types. Okay, the type 1 is integral dx by cos of x plus or minus a into cos of x plus or minus b. Actually, there are 2 sums. One is cos x plus a into cos x plus b. The other one cos x minus a into cos x minus b. That is, both are cos. Okay. Or dx by, both will be sin. Sin x plus a, sin x plus b. Sin x minus a, sin x minus b. So in type 1, actually there are 4 sums. Okay, both will be cos. It may be x plus a, x plus b, or x minus a, x minus b. Both will be sin. It may be x plus a, x plus b, or x minus a, x minus b. This is type 1. Type 2, you will have one sin and one cos. That is, sin x plus a, cos x plus b, or sin x minus a, cos x minus b. In the other one, cos is first coming, that is cos of x plus a, sin of x plus b, or cos of x minus a into sin of x minus b. So here 4 sums, here 4 sums. We are clubbing together as type 1, type 2. What is the step 1? When both are cos or both are sin, you divide the numerator and denominator by sin of a minus b. When one sin, one cos, divide numerator and denominator by cos of a minus b. This is the main difference between these 2 types. Actually, the step 2 is similar only. So, remember the step 1 clearly. When both are cos or both are sin in the denominator, divide the numerator and denominator by sin of a minus b. When one is sin and one is cos, divide the numerator and denominator by cos of a minus b. Clear? Now, coming to the second step, if you have x minus a and x minus b in the denominator, it may be sin, it may be cos, that doesn't matter. In the numerator, you have one sin of a minus b term. That you have to write it as sin of x minus b minus x minus a. X and x will get cut, you will get a minus b. If you have the 2 terms as x plus a and x plus b, you write sin of a minus b as sin of x plus a minus x plus b, so that x will get cut and you will get a minus b. Okay, remember these 2 steps. Actually, you note down in the formula page itself as a concept. For this type, these 2 steps. For this type, these 2 steps. Here also, only instead of sin there will be cos, otherwise the same logic only. So now I have explained to you for both the types what are the steps to be followed. Now I will do one sum in type 1 and one sum in type 2, so that you have to do 3 more sums in type 1 and 3 more sums in type 2. So this model will be very clear to you. This is a very important model. So definitely you should learn the steps, note down the steps in your notebook, and then you have to do the 3 sums in each type yourself. Okay. Now this belongs to type 1. That is, both the terms in the denominator are sin. I have taken sin of x minus a into sin of x minus b. This belongs to type 2. one sine and one cos. Here I have taken x plus a, x plus b, so that it will be clear. Both the models will be clear to you, right? Now, here both are sine. So remember step 1. You have to multiply the numerator and denominator by what? Sine of a minus b. So now I will write that 1 by sine of a minus b outside the integral, that is the denominator part. I will write the numerator part here, sine of a minus b. By this denominator, I will write as it is, sine of x minus a into sine of x minus b dx. So the step 1 I have introduced. Multiply the numerator and denominator by sine of a minus b. Now I am coming to step 2. I am having here x minus a and x minus b. So now what I will do, I will write this as it is. Okay, integral. This sine of a minus b I will write sine of x minus b minus x minus a. We are using these two and we are expressing that a minus b. Okay. Now the denominator you write as it is, that is sine of x minus a into sine of x minus b dx. So step 1 and step 2 we have introduced. Now you take this x minus b as capital A, this x minus a as capital B. So the numerator is sine of a minus b. You know what is the formula? Sine a cos b minus cos a sine b. So let us use that formula. We will get 1 by sine of a minus b outside integral sine a cos b. Okay, minus cos a sine b divided by, this is sine of x minus a sine of x minus b, of course, into dx. Okay. Now actually this is one part and this is second part. Either you can write them as two separate integrals or we can write within one integral. Now see here, this sine of x minus b and this sine of x minus b will get cut. We will get cos of x minus a by sine of x minus a. So actually my first part will be sine of a minus b integral cot of x minus a. Okay. Coming to the second part, the sine of x minus a and this sine of x minus a will get cut. I will get cos of x minus b by sine of x minus b. That gives cot of x minus b. So minus cot x minus b dx. Now both the terms are easily integrable, straight formula. So now we can write 1 by sine of a minus b. What is the formula for integral cot x dx? It is log mod sine x. So for the first one you will get log mod sine of x minus a. Okay. For the second one you will get log mod sine of x minus b. Close the bracket, then write plus c. Now if you see the bracket, it is like log a minus log b. We have to use the log rule. It is log a by b. So the final answer will be 1 by sine of a minus b into log mod sine of x minus a by sine of x minus b plus c. Do you understand? Actually the integration part is very simple. Only thing is you have to remember the two steps I told you. Multiply the numerator and denominator by sine of a minus b and then express the numerator sine of a minus b as, if it is x minus a, x minus b, write it as x minus b minus x minus a. Then use the formula sine of a minus b. Then the rest is easy. Okay. Now let us come to this type 2. That is I is equal to integral dx by sine of x plus a into cos of x plus b. Let us follow the same procedure. But here what is the first step? we have to multiply the numerator and denominator by cos of a minus b. Okay. So now I will get here, I will write that 1 by cos of a minus b out. The numerator will become cos of a minus b. The denominator we will write as it is. Okay. Cos of x plus b dx. This is the first step 1 we have finished. Then this cos of a minus b we will write as cos of a minus b. Here you have x plus a and x plus b. So how will you write it? It is cos of x plus a minus x plus b. Do you follow? Here it was x minus a, x minus b, so you wrote like this. Here it is x plus a and x plus b, so you are writing like this. By write the denominator as it is. X plus a, cos of x plus b dx. Now treat this as a as b. So now you get cos of a minus b. What is the formula? Cos a cos b plus sin a sin b. So now you will get 1 by cos of a minus b integral cos a cos b plus sin a sin b. Okay. Write the denominator as it is. Sin of x plus a cos of x plus b then dx. Okay. Now we are going to split as we did there. So if you look at the first one, cos of x plus b will get cut. You will get here cot x plus a. So 1 by cos of a minus b is outside integral. First we will get cot of x plus a. Now let us come to the second part. Here sin of x plus a will get cut. You are having sin of x plus b by cos of x plus b, which gives you tan of x plus b. So see the difference here. Here you got both as cot. Here one is cot and one is tan here. Of course this is plus and there it was minus. Now just we have to apply the general formula and we have to integrate. Cot of x plus a you will get log mod sin of x plus a. Okay. Coming to the tan, integral tan x dx is log mod secant x. So you will get plus log mod secant of x plus b plus c. Now this is like log a plus log b. You can write log ab. But actually here both were sine and it looked neat like this. Here one is sine and one is secant. So I am just leaving it like that. So let this be the answer. If you want you can actually combine both the logs. So do you understand these two types clearly? That is why I have done them side by side so that it will be clear to you. Step 1, what is the difference? Step 2, what is the difference? And then how we proceed further. Hope you are clear with these two types. So that if you know this, you will be able to do all the other 6 sums. Okay? Type 1 3 sums and type 2 3 sums. So hope today you have understood whatever new models I taught you and how to use integration by substitution and the 4 new formulae you learned. In the next video, we will see more formulae and different method of integration. Thank you for watching the video. If you like this, share it with your friends and classmates. Thank you once again.